Hi, my name is Noah Arnold, and this is my Physics Lab 2 project on the lines of charge experiment. The purpose of this lab is to help us better understand how to compute a charge from a line of charge like a rod. This will be a much more accurate model of what was actually going on in Lab 1 rather than treating it like a point charge like we did last week. Some fundamental principles that we'll need to understand while doing this lab are Coulomb's law, which describes how force can be found from an electric field, the force of gravity formula, which we will need to compare to find the actual charge later on. We need to understand Newton's third law that goes into the force of gravity, where we need to understand that they are an equal and opposite force. We also need to understand superposition, as in if we have multiple point charges, when you add them all up, it will equal that one electric field, and we'll need that for calculating the force of a line charge. For a quick review on what we did last lab, after creating a charged electrical tape by ripping it quickly apart from another piece of tape, we did what was shown in the figure here in order to find the charge of tape B. A quick review on some of the findings that we found that tape B was negatively charged in negative 1.9 times 10 to the negative 9th coulombs. The width of the tape was 0.018 meters, the length of the tape was 0.2 meters, the mass of the tape was 0.0002 kilograms, and the distance between A and B was 0.004 meters. Because we need to break the electrical tape into several different pieces, one easy way to do this is by using coding. If you look at this code here, you can see that I broke up each part of the tape into smaller pieces that could be considered point charges. Then, using superposition, we just add these charges together in order to find our final charge. After running the code, we get a figure that looks like this, which shows that the tape has an electrical charge, and you can see that the electrical force of the tape is right around 8.9 times 10 to the negative 6th. This is much a bigger force than what we found last week when we just considered it a point charge. In order to find the charge computationally, we can use the formula for charge of a line charge and then solve for Q, because we know that the force at an electric field is equal to the electric field times the charge. We also know that from Newton's third law, the electric force is equal to the opposite of the gravitational force. After plugging everything in and treating the tape as many point charges, I found Q to equal negative 5.9 times 10 to the negative 6th coulombs. Some assumptions that we made in this lab were that we were treating the tape like a line charge or a rod, and that we broke the tape up into many point charges. This is different from Lab 1, because in Lab 1 we treated it just as one point charge. We also assumed again that tape A and tape B had the same charge. We were also assuming that no charge got lost in the handling of the tape. We also assumed that there were no other forces going on, whether that be from the air, other electrical fields in the room, or human movement acting on the tape. To answer the what if and why questions, last lab when we treated the tape like a point charge, we found that the charge was negative 1.9 times 10 to the negative 9th coulombs, but when we treated it like a bar charge with several point charges located on it this week, we saw that the charge was negative 5.9 times 10 to the negative 6 coulombs. The difference here is nearly double the charge when we break it up into a bar rather than several point charges. The model gives us very different answers because they are used for different cases. The point charge is not as accurate because it assumes that the charge is located at one position and is stationary, whereas the line charge looked much more accurate to what we were doing in real life because tape is a straight line.